Hello friends, I hope all of you are fine at your place. So welcome to my channel. In this channel, as you all know, I try to give you the solutions of previous year questions which are asked in CSIR NET and GATE Physics exam. So today we will be discussing a question which was asked in NET December session in the year 2012. So let us read the question first. Input to a lock-in amplifier has the form VIT is equal to VI into sine omega t plus theta I, where VI is the amplitude of the signal, omega is the frequency, and theta I is the phase of this input signal. Now, this signal is multiplied by a reference signal of the same frequency omega, amplitude VR, and phase theta R. If multiplied signal is fed to a low pass filter circuit of cutoff frequency omega, then the final output signal is, and here four options are given. We have to calculate which one of them will be the correct option for the final output signal. So let us read from the basics. By reading the question, we can make a guess that it is a question from the topic electronics. So let us see here. VI, since the question is asking that there is multiplication of signal VR into signal VI, so we will simply multiply these two signals, VI into VR. That will give us the product sine omega t plus theta I, VI into VR sine omega t plus theta R. This is just the multiplication of the signals. Now let us proceed ahead. Now what we can do is we can simplify it and apply the formula to sine A sine B here, because in this question here sine omega t plus theta I into sine omega t plus theta R. So sine A into sine B. We will use here the formula. 2 sine A sine B is given as cos A minus B minus cos A plus B. So we can substitute this formula and rewrite this expression as VI of t into VR of t is equal to VI into VR upon 2 into cos theta I minus theta R. This will be cos A minus B minus cos 2 times omega t plus theta I plus theta R. This will be cos A plus B. Now we have simplified this expression in terms of the formula. We have to use now some basics involving the filter circuits in the electronics. So let us understand some basics, then only we can guess the answer from this expression. Now filter circuits are of basically three types. First is the low pass filter circuit. Low pass filter circuit allows frequency which is less than the cutoff frequency. So cutoff frequency is the upper limit, and so it will allow frequency from 0 to omega c. Now high pass filter circuits. High pass filter circuits, they allow the frequency which is greater than their cutoff frequency, which is omega c. So it will allow the frequency which is in the range from omega c to infinity up to the maximum value infinity. So this will be its lower limit. And the third types of filter circuit is the band pass filter circuit. The band pass filter circuit allows the frequency in the range omega c1 to omega c2. If the frequencies are in between this range, then it will allow, otherwise it will reject the frequencies and the region which is not falling in this range. And low pass filter circuits are made generally by R and C resistors and capacitors. High pass filter circuits involve inductors, capacitors and resistors, LCR. Similarly, band pass filter circuits also involve LCR, inductors, capacitors and resistors within the circuit. So we have understood some of the basic concepts involved in the filter circuits. Now we will use them. Now according to our question, we have low pass filter circuit with cutoff frequency omega. It is given. Now cutoff frequency for low pass filter circuit omega means that it will allow the frequency which should be lower than the omega. It should be lower than the omega, which is 0 to omega, not greater than or equal, not greater than omega. And now let us look at this term and observe it carefully. It involves two terms with cos. In this term cos theta I minus theta R, it is fine, no problem. in the next term cos 2 times omega t plus theta I plus theta r. We have to focus here 2 omega. Now 2 omega is greater than the omega, and omega is the cutoff frequency, so it cannot be possible that in low pass filter circuit it will now in low pass filter circuit it will not allow this frequency because it is greater than its the cutoff frequency omega, so it will not allow this 2 omega term. Now cos 2 omega term, this whole term will be rejected, and this circuit will allow only this term cos theta I minus theta r. This it will not be allowed, and will not allow due to the presence of this filter circuit. So, and we know that omega will be the maximum limit and 2 omega will cross this limit, so it will not allow this. And so Vi for t into Vr of t will simplify to just Vi into Vr by 2 cos theta I minus theta r. This will be our required answer. So the correct option is A. Let us see here. This will be our correct answer, A. So I hope friends you have understood the solution of this question. Thank you.